Okay, it's time to take a look at what happens when the exponent is negative. Let's take a look at the first example. We've got c to the power negative 7. Now, one thing I want you to remember is when you see this negative, it is not going to be, the final answer will not be negative. You cannot pull the negative out of the power, okay? Not gonna happen. What do you do instead? Okay, what we're gonna do is we're gonna rewrite this so the bottom is 1. We're basically making it a fraction. Now, how can you do that? Well, dividing by 1 doesn't change the number. I didn't really do anything, okay? I just made it look like it's a fraction. And then what happens with negative powers is they will become positive if you switch the top and the bottom. If you want to take this guy and put it on the bottom, it is going to be exactly the same, except the power will switch sign. Now, remember, if there is nothing left on the top or on the bottom anywhere, when you move things around, what's left is always 1. It's not 0, because if it was a 0, then it would be 0 in the answer. Okay, on the bottom, I already had 1, and now it will be multiplied by c to the power of positive 7. Okay, what happens when you move from the top to the bottom? The power switches sign. The negative power becomes a positive power on the bottom. Finally, when you multiply c to the power 7 by 1, that doesn't change anything. And again, you're just going to get c to the power 7, but it's going to be on the bottom. Okay, look at how it says express the final answer using positive exponents only. You cannot have any negative exponents in the answer. Okay, now let's take a look at the next question. This one says 10 to the power negative 6. Okay, so what do? Again, you're gonna go ahead and rewrite it as a fraction divided by 1, and then you're gonna take it and move it to the bottom. And when you move it to the bottom, the negative in the power disappears. Poof! Okay, not there anymore. And we will have 1 times 10 to the power negative 6. Nope. It's just now going to be positive 6 because we moved it from the top to the bottom. And on the top, we're still going to get a 1. Okay? And 1 times anything is just that number. Final answer will be 1 over 10 to the power 6. Let us generalize that. A to the power negative n will be 1 over a to the power n. That's your rule with negative exponents. Okay, let's write this here. Now, here is going to be very interesting. Look, for c and d, we get a negative exponent in the denominator. What does that mean? Okay, let's see what happens. We got h to the power negative 6. Now, to rewrite this, we need to move this h from the bottom, and this time we're moving it to the top. Before we were moving it from the top to the bottom, now we're moving it from the bottom to the top. And you can hopefully guess what happens with that negative as you switch it around from the bottom to the top. Well, it'll become positive. It'll become, well, 1 was there, and then it'll be h to the power positive 6. Now, what will be left on the bottom? Now, you could say nothing, but it's not going to be nothing. Remember, if there is nothing left, you leave it as 1. Okay. On the top, 1 times anything is just that anything. So you're multiplying something by 1, that something doesn't change. We get h to the power 6. On the bottom, we get 1. But dividing by 1 doesn't change anything, and you get h to the power 6. Okay, let's put that here. Similarly, you get 1 over 5 to the power negative 2. But it's on the bottom. We want to move it to the top. We'll take it, move it to the top. Every time we move it, it'll become from negative to positive. Okay? It'll switch sign. We'll get 5 to the power 2 on the top multiplied by 1, but that doesn't change. And on the bottom, there will be just 1. And then 5 to the power 2 over 1 will just be 5 to the power 2. It's actually going to be 25. Now, I want to generalize that before we submit. 1 over a to the power negative n becomes, We just move it to the top. It becomes a to the power positive n divided by 1, but we don't need that. Okay, let's see. So here we get 5 to the power 2.